And it's again, it's because of this lag from CO2 levels to how the temperature responds to that. But now the oceans, I keep coming back to the oceans. What
No,
else can I
you're
say?
right. Go ahead.
But
That's
yeah,
your
now you
specialty.
got you have 136 zetajoules of energy in the upper 500 meters or so. And because the thermal hailing flow is slowing down, that heat is diffusing into the atmosphere.
Yeah, I watched your
And
sea
that,
ice. Go ahead, finish them.
and that diffusion is just going to warm the thing up.
Well, we can talk about your sea ice melt video, which was very informative. Coming back into this, it's like, holy shit, we're really disrupting these patterns and cycles that have, we've taken for granted. It's been going on for millennia. Let's dive in to that one. I have my notes. There's a lot to talk about. So, okay.
Nice. Now you see why I split into two parts. Well, first of all, if I tried to upload the whole thing at one go, it'd probably still be uploading.
Oh my God. No, I always get a kick out of the graphics because I'm very visual, so that helps. But yeah, just the
Yeah, it's
cycle
same
of
here.
it.
I'm visually oriented, so yeah.
Okay, because I appreciate it, because like yeah, the way the wind is going and the currents and all that's getting disrupted essentially with warmer water and the Atlantification you talked about. Just if you wanted to elaborate anything, or just it's
Oh,
very well done. I'll link
base,
it.
basically, because you got all this warm, salty Atlantic water now starting to infuse into the Arctic Ocean, it's actually changing the physical characteristics of the Arctic Ocean. But then there's a whole lot of things. The Arctic Ocean is being restructured. The vertical structure is changing. You have all this riverine input. The Mackenzie, the Ob, the Lena rivers. You got all this riverine discharge. You got this big freshwater being introduced. Part of it is more precipitation, more melting of upper level glaciers and stuff like that. So you have that. You got the pacification of the western Arctic, in the Chukchi uh, uh, Sea area. So you're bringing in now the Pacific water tends to be not as salty as the Atlantic water, but both are still saltier than the upper layers of the Arctic Ocean. So you're changing, and we're seeing the halocline getting shallower in the Arctic Ocean. That's going to have significant implications for productivity, what happens to to the ice and so on. But no matter what, whether it's from the Atlantic side or the Pacific side, the flow rate into the Arctic Ocean is increasing.
Very interesting.
It's warmer water, so it's bringing in warmer waters. Guess what that warmer water is going to do? It's going to melt the ice. The reason why we're seeing the sea ice disappear is not so much we get some open water and then you have the sun energy being absorbed. The question now is, why was there open water to begin with? And the
Right.
answer is you have the warm water from the Pacific and the Atlantic contribution diffusing upward, melting the ice from below. That's why. And now you're hearing, and this is something I wanted to discuss today. Now you're hearing all the things about AMOC, the Atlantic Meridional Overturn Circulation slowing down, and somebody, it's going to stop in a couple of years. Hold your horses. Okay.
Okay.
Is, is AMOC slowing? Yes, it is slowing. There is measurements that show that it is slowing. That is taking place. Absolutely. And AMOC, of course, is where the deep water formation takes place. So you get the vertical sinking. So as that water sinks, it kind of pulls the Gulf Stream along with it. So AMOC is slowing, which means the vertical flow is slowing, which means the Gulf Stream is slowing. Now the
Right.
Gulf Stream is really, really warm. Warm water expands, sea levels rise. But now you're hearing people saying it's within 2 years of collapsing. Well, in order for that to happen, the rate of slowdown has to dramatically increase. And the data I'm seeing right now does not really support that. In
Okay.
fact, the data I'm seeing now shows, well, we still got some warmer than usual regions of sea surface temperatures in the area, I'm not convinced that it's going to suddenly stop within 2-3 years. It could happen. It's a possibility. I think it's, I'm not going to sound like the IPC, is highly
Okay,
unlikely.
sure.
But I would say the probability is low of that happening. Probably less than, you know, 0.04. I'll put it that way. But
Okay.
in the past, when AMOC slowed and stopped, there was at least a hemispheric cooling. Because don't forget, the conveyor belt is the heat distribution mechanism for the planet. Right? Brings warm stuff from the high latitude, cool stuff from the high latitudes to the tropics. So when that stops, you don't have that transport of warm stuff up to the high latitudes. So yes, at least hemispherically, there's a cool down. And then that can promote ice sheets. And the ice sheets grow in size and depth and they expand southwards. You have a bit of an ice age. What was the difference from when that happened in the past to why I don't think that will happen now? Ocean heat content.
Okay. I was gonna say
This is so
thermal
much
inertia.
energy.
Ocean heat
Uh,
content?
uh, Yeah, it's thermal inertia of the ocean because of all that heat content. I think what will happen is that instead of a hemispheric cooling, there will be a regional cooling. So Iceland, UK, Scandinavia, France, Germany, the Baltic states, yeah, they'll probably experience some kind of colder, much colder weather. So they will get some
Okay.
snotty stuff.
I understand I'm visualizing this. Yeah, there's going to be regions where it gets colder, and it seems like it's the northern Scandinavian countries who are at risk for that because of this.
It's really interesting because, and we've talked about this before, but when you look at, surface temperature on the planet Earth, there's always that cooler spot right by Greenland.
Yeah.
It always is, because that's where you have the freshwater dump and that kind of stuff. Now, in both cases, in the past when AMOC stopped, or if AMOC stops now, in both cases, ocean productivity will decrease dramatically, if not go to zero, because you don't have the vertical mixing. So the nutrients eventually get used up.
Okay.
And then if you use up the
Interesting.
nutrients, there's nothing for the phytos to do. If you don't have the phytos doing productivity, what did the zooplankton go to eat? Who's going to eat the zooplankton? And so forth. And we see evidence for this. We're looking at the isotopes and all that kind of stuff. So we see that. So that's going to be a very dire consequence. Don't forget, as the conveyor belts flow southward, part of it upwells in what we call the Antarctic divergence zone. It upwells, it brings nutrients with it. Southern Ocean is very, very productive because of those nutrients. Well, if you don't have the conveyor belt, you're not going to have that upwelling. You're not going to have your Southern Ocean productivity. So your baleen whales, your krill, your orcas, right? They're going to be impacted badly.
It's like the collapse of the food chain, the ecosystem type situation that's headed straight
Exactly.
for us.
Now, here's another thing, and I've got a video. I actually have to edit it. The question now, and this what may affect whether AMOC increases its rate of slowdown, decreases more rapidly or not. Remember, I just mentioned all that fresh water being introduced into the Arctic Ocean.
Right.
The question is, what happens to that? Does it stay in the Arctic Ocean where it helps to restructure the vertical structure of the Arctic Ocean? Or does it get flushed out into the North Atlantic? That's a big question. Part of it is tied into what the Arctic dipole is doing, because the Arctic dipole, depending on where the high and the low pressure systems sit, and thereby governing atmospheric circulation, either the ice gets pushed out the Fram Strait or it kind of kept within the Arctic Ocean. Well, the same mechanism could determine whether that fresh water stays in the Arctic Ocean or it gets pushed out the Fram Strait. If it gets pushed out to the Fram Strait, you're going to have that fresh water lens and on top of the ocean, in addition to the Greenland melt. So you could be really putting a major pile of fresh water into the North Atlantic, really, really diluting it. Under that scenario, I can see the AMOC drastically slowing down, if not coming to a stop. But keep in mind, Wally broke, of course, this is before humans started messing with things. He showed that for the conveyor belt to shut down takes several decades. About
Okay,
30,
there's a
40 years
lag.
is what he estimated. And yeah, team from Dalhousie University in Dartmouth, Nova Scotia, they've been measuring slowdowns in AMOC for the last 10, 20 years or so. So that that is a scenario in which the AMOC could increase the rapidity at which it slows down, if not shuts down.
Which will then you talk about will lead to more sea level rise because everything's just gonna it's not being pushed anymore. It's gonna just flood Florida.
Well, well, what's happening is if you're not moving that water northward, it's just staying in place, not under the assumption the Gulf Stream stops flowing. Well, it's going to keep absorbing solar energy, and it'll just keep expanding. Warm water expands. So that's why you get the sea level rise. And it's going to be disproportionate because you're going to have more of a rise at lower to mid latitudes than at higher latitudes because
That's
the
so
warmer
interesting.
water. So you're going to get this imbalance, which could actually set up some interesting, you got sea level. If the sea level is higher here and lower here, water flows down the pressure gradient. That can set up a whole bunch of fun physics.
But underneath, I mean, it is climate change, right? Like things are changing simply, but it's dramatic on the ground.
But here's the thing also, everyone's talking about the Gulf Stream stopping. Okay, the Gulf Stream, depending where you're at, goes down to about 800 feet on average. The water that flows into the Arctic Ocean from the Atlantic side is the North Atlantic intermediate water. Sure, there's some surface flows from when the Gulf Stream becomes the North Atlantic drift, through the Barents Sea opening, shallow shelf processes. But the main influence of the Atlantic water, the main thrust going into the Arctic Ocean is the North Atlantic intermediate water, which is usually about 1,000 to 1,500 meters down, and that's what's moving in. So I still see the North Atlantic intermediate water with its higher heat content still flowing into the Arctic Ocean, that heat still diffusing upwards to melt the ice. Now, when we're talking about warm water moving in, it's not like we've got, 20 degrees C water. The temperature of water is 20 degrees C, which is, it's basically, what the hell, like 68 degrees or something like that.
Yeah.
No, all it has to be is just greater than minus 1.8 C. Sea ice in the Arctic Ocean forms at minus 1.8 C. All it has to do is just be warmer than that. And the water that flows in is about 1, maybe up to 5 C. But that's
Okay.
enough to keep the ice either from forming or helps it melt earlier. It doesn't take much. And we're seeing that heat moving in.
And in your video, you talk about the blue ocean events um, happening earlier and earlier, but possibly by the mid 30s. I'm sorry, the mid 2030s, but could be sooner than that.
The, the models seem to indicate that the first blue ocean event will occur sometime in the next 1 to 3 years. And that means there's no ice anywhere in the Arctic Ocean. And
Damn.
that may last a month or two. Then they talk about lasting 2 to 4 months of the year, and then 4 to 8 months of the year. And then finally, year round, no Arctic ice. By the time, what the thinking is, that will take place by the mid 2030s, that there will be no Arctic sea ice year round.
Okay, it's a progression, but yes,
It's a progression.
and the
But we're
other.
seeing
Go ahead.
signs now, for example, around Greenland, you got all the Canadian archipelago, the ice really kind of hangs on there. That's starting to break up. There was some signs of starting to break up just a couple of weeks back. And don't forget, September is the ocean summer. So we're just
Right.
now approaching minimum, sea ice minimum. So,
Oh no.
and of course, we're losing the multi-year ice. That's where
Right.
you get your albedo from. So you can have ice, but if it's frazzle or greasy ice, there's still going to be some sunlight penetration through that. And we're losing the multi-year ice, the 3, 4, 5s and so forth, sea ice. We're losing that.
Yeah, we're going full speed ahead. This is our future. There's no turning back. The ice is not coming back, at least in our
It's
lifetime and
highly
beyond.
unlikely. It's
Sorry.
interesting and scary.
I know it's alarming because it's happening so quickly, like in a human lifespan, right? But the other thing with your
Yeah.
video was the warmer water was entering the Arctic. Was it 7 months? Or yeah, I had yeah, okay.
Well, it's the term we use the term called residency time, and the residency time of this warmer infusion into the Arctic Ocean has increased from about 5.5 months to over 7 months. That's another month and a half, 2 months longer. So now, if you got warmer water that's lingering in the Arctic Ocean for longer, we all know what that means.
Again, the sea ice is at risk. The ecosystem is
See,
at
it's
risk.
going to melt the sea ice. Yeah, it's crazy.
And it's happening so quickly, and that's part of this issue. 2020s, 2030s, like that's right around the corner. It's right here.